Hello, my name's Sarah. I'm here today with my colleague Chris, and also, like he said, we're scientists at Applied Ocean Sciences. We do a lot of biological, physical, and chemical oceanography studies. Today, what we're going to talk about is COVID-19 and ship noise, and the rare opportunity that the changes in global shipping during this year's shutdown has provided us in terms of studying anthropogenic noise in the ocean. So it's no secret that life in the ocean relies on sound. In air, light travels very easily and we interact with our environment using our eyes and optics for sensing purposes. But in the ocean, the light doesn't travel as far, but on the other hand, the sound does, as you can see in this picture. The sound or the acoustic waves in the air travel really slowly, but underwater, they travel from the same source location a lot faster and a lot further. So life in the ocean has been selected from this quality to rely on sound for communication, feeding, socialization, and just a general sense of sensing the environment. Many marine animals, and most notably marine mammals, have evolved highly extraordinary hearing and complex voices in order to take advantage of the way that the sound propagates through seawater. So what you're looking at here in this picture is an example of humpback whales feeding, and they're doing what's called a bubble curtain, where they'll blow bubbles under a school of fish to concentrate the fish into a small area, and a single humpback whale is going to stay under that group of fish and make really loud vocalizations to drive the fish upward into the bubble net, while all the family members feed at the top. It's very complex, really good coordination, all using sound. And these sounds that the humpbacks make are so beautiful and so complex. And often, sometimes it is, sometimes it's not clear why this sound sounds the way that it does. But what is very clear is that these marine animals don't deserve to live in our world. They've evolved to live in a world with noise from breaking waves, sea ice, seismic disturbances, and in addition to other natural organisms in the ocean like snapping shrimp or bustling reef life. But they have not evolved to live in the world filled with today's seismic exploration, sonar, construction projects, or ships. And now these are the type of anthropogenic noises that dominate the soundscape in the ocean. And yep. So what you're going to hear in this recording, hopefully, you might have to unmute, Chris. We can skip it if not. We encourage you to go back and listen to these on your own. The marine animals aren't the only, the whales aren't the only animals that use acoustics to communicate and are affected by human-induced additions to the soundscape. It's been shown that loud noises from ships and other human activity can cause stress in many different species. Loud sounds can have negative impacts on scallop larvae, drive fish away from their feeding grounds, krill and zooplankton can be dispatched by acoustic beams, and deformities have even been detected at a cellular level in many lobsters. And one of the main sources of anthropogenic noise pollution in the ocean is shipping traffic. Because of the rise of commercialization in global economics, commercial shipping has increased significantly over the last 50 years. And this necessarily isn't a bad thing. We've heard lots of wonderful geospatial advances in the way that we're talking about and that we're starting to plan ocean operations throughout the past couple days of this conference. But what it does mean is that there is continuous persistent background noise in the ocean that didn't used to exist there. And just like with human ears, the short, loud blasts of sound can often cause permanent physical damage to the marine animals. So this leads us to the difficult question of whether this noise is something that the ecosystems and populations can adapt to or not.
So like Sarah said, the real question is, who cares? Why do we care about the increase in ambient noise in the ocean? And so we're going to do a demonstration. This is a recording of orcas in Puget Sound, Washington, communicating. And you can tell that their vocalizations are quite loud. Hopefully you can hear them a little bit. But now there's something else that's starting to happen, and that is that a ship is starting to move into the area, so you can't hear the whales anymore, and in fact, probably can't even hear me talk. So if it matters for you being able to hear me talking to you, it probably also matters for the orcas trying to communicate to each other. So what that means is marine acousticians, such as ourselves, have sort of a double life as scientists and detectives, because studying anthropogenic sound is very difficult because these days it's really, really hard to find a control. In other words, there's nowhere in the ocean we can go where we don't have some input of anthropogenic sound from ships, from seismic exploration, from sonar. But this COVID-19, which has caused devastation worldwide, did provide a very unique opportunity for scientists because the global shipping patterns changed dramatically during the pandemic. So if we look at this plot right here, which is a plot of global AIS shipping density provided by our partners at Spire. Spire and AOS are both proud to be Esri startup business partners. And so we work together to create this global map of shipping, where on the left, we have the shipping density in March of 2019. And on the right, we have the shipping density in March of 2020. And so if I slide this back and forth, you can see small differences. So I'm going to do it again, but direct your attention right here to the central North Atlantic, where in 2019, there's more of the darker colors than there is in 2020. Similarly, in the South Atlantic, more of the darker colors in 2019 than in 2020. And so overall, there was a fairly significant decrease in ship traffic between 2019 and 2020 due to the COVID-19 pandemic. If we plot what the impact of that decrease in shipping traffic was on ambient acoustic noise, we get this plot right here. And so what we did is we modeled every single ship out to everywhere, every hour for 2 months, and averaged what the ambient noise was over the course of the entire time. That amounted to a server heating my house for several weeks. But what you can see is, again, if we look in some of those same regions, 2019 is on the left, 2020 is on the right. So let's look at the central South Atlantic this time, between South America and Africa. You can see there are areas that are slightly redder in 2019 than 2020. And the purpose of this figure isn't to show you an enormous stark difference. It's actually to show you that the difference appears at first examination to be very subtle. What you see is in that central South Atlantic area, and indeed all over the entire planet, you see a decrease of order 1 to 2 or 3 decibels, that the ocean was quieter in 2020 during the pandemic than in 2019. And you might ask yourself, who cares? What's 1 or 2 decibels between friends? Well, it turns out if you are friends with a lot of marine mammals, 1 or 2 decibels matters a lot. For example, to this humpback whale and her calf. Let's say 2 humpback whales are trying to communicate offshore in Hawaii, where they migrate every year, and look at what the impact is of that very slight and subtle increase of sound, due to shipping traffic is. So this right here is a plot of the Hawaiian Islands. You can see them in black, and the acoustic emissions from a single humpback whale call in the Hawaiian Islands. In this particular plot, purple is loud and yellow is quiet, and you can see some masking by the islands. But that's not the only thing that masks the sound and makes it difficult for them to hear each other. If we take that same plot, but instead of showing a monthly average, show a single snapshot, this is what a single point in time chosen randomly off the Hawaiian Islands looked like during April 2019. And this is what that exact same time period looked like in April 2020. So 2019, lots of red. 2020, not so much red. So you can tell that it's definitely a lot louder in 2019 than it was in 2020. But again, who cares? Well, going back to that whale, the whales care quite a bit. This plot right here shows you something called signal excess. Without getting into the math, what it shows you is how much louder than the ambient noise that same whale call is in 2019 on the left and in 2020 on the right. So essentially blue and yellow is where another humpback whale might be able to hear that mother with her calf that we were talking about if she wanted to communicate with them. So it's a fairly large area in the Hawaiian Islands. That's 2019. Let's look at what it looks like in 2020. That same whale would be audible in this region in 2020, which is an area over 3 times the size in 2020 versus 2019 because of that small reduction of 3 decibels. So if we think a little bit about what a decibel is. A decibel is a logarithmic measure. So 3 decibels actually represents a doubling of acoustic intensity. So that means there are significant portions of the ocean that had half the acoustic energy in 2020 during the pandemic versus 2019. And you might end this talk with some pessimism because you might think, well, the shipping traffic is going to increase after COVID-19, and that's true. But myself, I find these findings to be sort of a reason for hope or a reason for optimism because there's a ship traffic right here, so you might not be able to hear me. But the decrease of 3 decibels might allow humpback whales to vocalize and communicate over areas 3 times the size, means that if we were to find ways to reduce our acoustic footprint, but by what seems like very small amounts, like 1, 2, or 3 decibels, through either some form of international regulation, regulating, engineering plants on ships, limiting areas where ships go. If we were able to decrease those acoustic emissions by just a decibel or 2, we could vastly reduce our impact on the marine mammals, which suddenly makes solving some of these problems seem obtainable. And so with that, I'd like to thank all of our collaborators on this project. We worked extensively with everyone at Applied Ocean Sciences, our friends at Spire and our friends at Esri, as well as some friends at NOAA and a variety of other sources. So thank you very much for your time.